Hi everyone. I hope you're doing well. I hope you're ready to get back into school. I'm kind of excited to get started. The break was really nice, although I did not get to go to Disney and get to wear my ears, so I'm wearing them for you today. But I am ready to start back in and working with logarithms. So let's see what you remember. I posted your first assignment is going to be this warm up, and we'll see what you remember from that. And I'm going to go through those answers with you right now. See how you did on it. The first one, the log base 10, there's no number there, which means it's a base 10, of 4p minus 2 is equal to log of negative 5p plus 5. Since both sides are equal, they both have log, they both are base 10, that means this part has to also be the same, if those are equal to each other. So 4p minus 2 has to be equal to negative 5p plus 5. So we're just going to solve that simple linear equation. So we're going to add 5p over to this side, and we're going to add this 2 at the same time over to this side. So on this side we have our p's, 9p, and on this side we have 7, 9p equals 7. Divide both sides by 9. You can leave it as a fraction or a decimal. I'm just going to leave it as fraction. P equals 7/9. That would be that one. Okay, number 2. It's a little different because it only has log on one side. So it says negative 2 times the log base 5 of 7x equals 2. Easiest thing to do is I'm going to move this negative 2 over to the other side. So we have log base 5 of 7x equals negative 1. Since there's only a log on one side, we're going to rewrite it in exponent form. Remember the circle method where you do a little circle around? That means 5 to the negative 1 power equals 7x. 5 to the negative 1 power, that's just 1/5. 1/5 equals 7x. Times by 1/7 to get rid of that 7, you get 1 over 35 equals x. You could have it as a decimal, but it's just as good to put it as 1 over 35. Of course, you could always check it. If you plug in 1 over 35 here, 7 over 35, that would be 1/5. So log base 5 of 1/5 does equal negative 1, so it works. Number 3 is a little bit different. It says log of negative m plus 2 equals 4. There is not parentheses around that. So it's not the log of all of that, it's just the log of the negative m. And then plus 2 equals 4. So we're going to get the log part by itself first. So we're going to subtract this 2 over to the other side. So you have log of negative m equals 2. This is a base 10 because there's no base written there. So rewrite it in exponent form. That's going to be 10 to the second power equals negative m. That's 100 equals negative m. And then just divide by the negative 1 or times by negative 1. So m equals negative 100. So if you put negative 100 in here, the opposite of the negative 100 turns this to a positive 100. So 10 squared equals 100. It works. Okay, this one looks like a lot. Whenever you have two logs on the same side, that means that you can write them together with one log. It's got minus in the middle. Minus goes with division. So these both have the same base. We're going to rewrite that as log base 6. This goes on top, x plus 1 over, this one goes on the bottom. So we've put this and this together as a fraction since they both had log base 6 with the minus in the middle. Minus means division. This side stays the same. So now this one is kind of like the first one because we have logs on both sides. This is log base 6, this is log base 6, which means that this part has to be equal to this part since they both have log base 6 on them. So x plus 1 over x has to equal 29. Let's see, let's solve this as a proportion. So let's put a 1 under that and cross multiply. So move this up a little bit. X plus 1 has to equal 29x. Minus this x over to this side. You have 1 equals 28x. Divide by 28. X equals 1 over 28. 1 over 28. That's your answer. Hopefully you did okay. If you didn't, that's okay. It was a warm-up. But hopefully it makes sense now that we've gone through it together. So let's move on.